welcome back. Today we're going to be talking about simplifying radicals. Let's go ahead and take a look at some review. So here we're going to review what we know about square roots. So the square root of 25, we know that to be 5. And we know that because 5 times 5 is going to be equal to 25. When the square root of 81, we know the square root of 81 is 9. And we know that because 9 times 9 is going to be 81. But how could we solve the square root of 45? Because that's not a perfect square. We don't have two numbers that can multiply to each other. Today we're going to learn how to do just that. So let's go ahead and take a look at our rules. So when simplifying a non-perfect square root, we're going to factor the number under the radical into its prime factors. We're going to group any pairs of identical factors to pull out of the square root, leaving any remaining factors under the radical. So let's try that for ourselves by doing example A. So here in example A, it says simplify the square root of 200, and your answer should not contain any fractions or decimals. So we've got the square root of 200. We can't just type it into our calculator because that will give us a decimal, which we're not looking to do. So what we're going to do is we're going to factor the 200. So we've got 200 and we're going to break it down. Now you can break it down lots of different ways, but if you've got an even number and you're not sure where to go, you can always divide by 2. So if I divide 200 by 2, I'm going to get 102. So that's my first one. Now 2 is a prime factor, so I can't go any further with that. But 100 I could break down to 50 and 2. And again, I can't go any further with the 2, but I could break down 50 again to 2 and 25. And I could break down that 25 again into 5 and 5. And now there, I've got all of my prime factors. So now I'm going to look for groups of 2. So I've got a group of 2 here, and I've got a group of 5 here. So I'm going to pull out the 2 and the 5. So 2 times 5 on the outside of the radical, because they have friends, they were able to go outside together. This 2, however, is left by itself, so it's going to stay inside the radical because it did not have a friend to go outside with. 2 times 5 is going to be 10. I'm going to multiply those things on the outside of the radical. So I've got 10 square root 2, and that is my answer. That's as simplified as I can go. Notice no fractions or decimals in my answer. Now let's take a look at example B. Here we are at example B, and it says simplify the square root of 512. Again, no fractions or decimals. Now, I've got an even number, and I could go about dividing by 2 again, but I'm going to try and go a little bit faster. I want to get bigger numbers that I can multiply together. So I'm going to choose 64 times 8. If I do 64 times 8, that does give me 512, and I'm a little bit closer to getting to the end of this whole thing. So now I've got 64. 64 I know is 8 times 8, so I know that I've broken that down a little bit more. I got 8 and 8, so I know that's going to break down to 2 and 4. And again, 2 and 4. And then I can break down my 4 to 2 and 2. Same thing, 2 and 2. And then my other 8 that I didn't touch yet, I can also break down to 2 and 4. And again, 2 and 2. So now I've got all of my factoring done, and I've got a bunch of 2s. So I've got to remember that wherever a stem ends, that's one of my 2s, and if I have a group of it, I can pull it out. And I just have to be very careful. So I've got a group of 2s here, so that's 1, 2 outside. I've got another set of group of 2s here, so that's going to be another one on the outside. I've got another group of 2s here, so that's going to be another 2 on the outside of the radical. And I've got one more group here for another 2 outside the group of radicals, which leaves just this 2 by itself inside the radical. So it's going to stay inside the radical, and I've got 2 times 2 times 2. So 4 of those is going to give me 16, the square root of 2, and this is as far as I can go. Now let's take a look at the next example. So here I've got the square root of 45. So again, this time, unfortunately, it's not even. It's not divisible by 2. So I'm going to have to think of something else to multiply by. So I know that 9 times 5 is 45. So I've got 9 times 5. And then 9 can be broken down. 5 is prime, so it can't go any further than that. But 9 can be broken down to 3 and 3. So now I'm going to look for my groups. So I can see there's a group of 3 here. So that 3 is going to be on the outside. The 5 has nothing to join it, so it's going to stay on the inside. And I've got 3 radical 5. Now let's take a look at the last example. Here on our last one, we've got 2, the radical of 108. So the 2 is going to stay on the outside. We're not going to mess with that. That's going to just wait for whatever numbers we bring out in order to be multiplied by it. So now we've got to just factor out that 108. Again, it's an even number, so I'm going to pick 2. So I'm going to get 54 and 2. And again, I know 54 can be broken down to 9 times 6. So I've got 9 and 6. I can break that 6 down to 2 times 3. And that 9 to 3 times 3. So now again, I'm going to look for groups of 2. So I've got a group of 3 here, so that's going to go to the outside to be multiplied. I've got another group of 2's here, so that's going to go to the outside to be multiplied. And I've got this 3 just by itself, so it's going to stay under the radical toward the 3. Now, if I had more than one number that was left alone, so if I had a 3 and a 5, for example, they're not a group, they can't be pulled out, but I would just multiply them together to end up with 15. In this case, 3 is by itself, so it has nothing to multiply with. So I'm going to be multiplying 2 times 3 times 2. So 2 times 3 is 6. 6 times 2 is 12. And I end up with 12, the square root of 3. That brings us to the end of this problem. It also brings us to the end of this set of notes. If you like this video, go and throw us a thumbs up. If you love this video, go and throw us a sub. And we will catch you in the next one.